Okay, so we can probably start. Let me just verify that I can switch it. Yes. All right. So, uh, this talk, basically, there is an issue with dependency management in C++ and an eternal one, eternal struggle. Now, TLDR of this talk is basically how on a greenfield project where I can basically change anything I want, do it however I want. I just took a combination of CPM and Con to leverage them for both build reproducibility, or let's say, let's go not as far as saying build reproducibility, but um, build dependency reproducibility. At least we need to track what we're building with. And that was my initial so. But also, let's not create hurdles for developers, because usually the developer who builds the project on their local PC does not care at all about reproducibility or any of that. This is only important for maybe paperwork or some essay, something like that. Okay. Uh, so you need to make sure that it is usable as much as possible. Make it a pay user to work with Conan cache and things like that. So, long story short, um, I tried using log files, and also I tried using CMake presets to make it all work relatively easily. Also, I addressed an issue where a user preset is needed. So basically, when you need to change something when you need to change something in CMake presets, the usual approach that is told to you is to use CMake user preset. But if you want to change something in a default or base preset somewhere deep in the hierarchy, that leads to you creating my dash name of the preset amount of presets in the same kind of hierarchy. So we end up with 1,000 lines of boilerplate in JSON, to say the least. So that was addressed. Also, we can use dev containers to improve the rule press setup. It's not as supported as I would have wanted, but everyone has access to VS Code, I guess, so it's still fine. And if you don't want to, you don't have to use that containers. Obviously, all of that, reproducibility and things like that are guaranteed by some kind of pipeline logic in continuous integration. And okay, let's see how much I can do. I have prepared these slides during the second part of this day. So um, please don't be too judgmental. And if you have any questions, just stop me and I'll try to answer shortly. And if your question is answered by any further slide, then that is also fine. I mean, I can talk about that and we can move on. But just for the overall overview, let's try to give a perspective from this. So, yeah, as I said, no standard way as far as I know, no standard way, because I read a blog post about, or a series of blog posts about common package specification, and as far as I'm aware, it even had some uh, proposals to the what's it called, ecosystem evolution group or something like that. but I don't know how it ended up. So maybe we will have something more or less standardized one day. I don't know. So check it out. Kickware has a few blog posts on this topic, and CMake and the latest CMake has even support for whatever their proposal is. So yeah, that's um, that's quite painful to do dependency management in C++, especially when you have an older project and usually it has locked up way of doing things and you wouldn't even be allowed to change anything because firstly, why change whatever works? Secondly, it may have to be changed because, for example, you want to introduce new dependency or you want to remove an old dependency, or the developer in your group just doesn't even have a clue how to add or remove dependency, or they have to go for a special person to do it for them, or any of that combination of things. So I had a rare opportunity to start a new project in C++ with new defaults and to introduce new defaults or and trying to address those kind of problems, ecosystem issues with the latest available tools to us. And the reason I'm doing that is that what I wanted to do for my small group of developers, and everything that I'm gonna say is, of course, very subjective. Your case or your mileage may vary, and it likely will. For my concrete use case, again, a greenfield project, a small group of developers, like 3 developers, doing or maintaining 5 to 7 projects. And that means that there is not much time for this kind of maintenance or playing with build systems and things like that. Okay, uh, things needs to be delivered, and um, what this means that I want to come up with some kind of setup that allows almost zero level of maintenance, human maintenance, which means that it should be quite automated, or whatever maintenance needs to be done, it should be like minimal, like bumping a few versions, maybe, I don't know, like fixing some logic or changing logic, but adding dependencies, removing dependencies, it should be it should be smooth and painless. Yeah, and I also like the situations where there is not much cognitive load put on a single developer because you cannot realistically expect from every single one of your colleagues to know this, to like editing CMake files. I assume nobody likes editing CMake files. Or to even understand how software build systems work. I know that it is kind of a prerequisite if you want to develop in C++ that you have to be a build system expert for some reason, but maybe it doesn't have to be that bad. So when you hire a new colleague from university or after that, directly after finishing the university, you or he would not be in a sink or swim situation. So anyhow, yeah, and again, I think there is a tendency. It is maybe a biased view, but I think there is a tendency for C++ developers to use a hammer for every nail, and that hammer is C++, and just they try to invent things that are solvable in C++, but maybe there are other tools for that. So, yeah, again, disclaimer, optimal means something different for me and for you, or likely will. And again, and about listing the criteria, that's a lie. I had no time for this. But we can speak about this just verbally. What I want this to fulfill is basically I've addressed many of these points. Just for a developer to be able to add or remove both external and internal dependencies. By internal dependencies, I mean your company libraries or small reusable pieces of code, subroutines, I don't know, whatever you package them into. And external dependencies are usually just open source dependencies with permissive licenses that you want to use in your project. And again, besides the usability aspect, I just want to be able to go a few versions back and be able to tell quite confidently that I know that when I check out 5 Git revisions of, or I don't know, go back had this character 5, that 5 commits back, my project was successfully building with these kind of dependencies, which allows you to, which allows not you, but your other colleagues from other teams to develop those dependencies, those internal dependencies, and not fear that much for the situation when they break your code, because then the developer becomes kind of lost or doesn't know what to do next, because it just builds from master. Okay, master is broken. What do I do next? Then then they get upset. Well, so it's better to uh, fixate those dependencies. But if you fixate them, which is the case when you use like Git submodules, then you have to bump them all the time, which is another kind of radical solution to the issue. So I am trying to find something in between that may not satisfy both sides to 100%, but with some 20% effort, let's just satisfy 80% of the requirements from both sides, okay? Yeah, maybe even you need reproducibility for regulatory topics, which is a case for our team. I work in medical development, so we do need to be able to reproduce our software. And also, it is often the case that you have some kind of an old release of software which you need to somehow provision. And by that, I mean, for example, you need to do a vulnerability lookup in that software or in the whole system. I do embedded Linux, so I'm speaking in terms of like whole Linux images or Docker files, for example. And you might have heard about cybersecurity resilience acts and things like that. So now you need to quite often come back to your old releases and do something with them. And to do something with them, to begin with, you need to be able to build them, okay, logically. And you don't want to spend 2 months trying to find a perfect set of dependencies with which it was building back then. So we are trying to eliminate this kind of issue, or at least mitigate it, if not eliminate. Okay. Now, maybe before starting the talk, it would be interesting to hear about the level of audience. So please raise your hands who is using CMake at their project's job, or maybe not job, or maybe like, okay. So also, if you use fetch content or CPM, please raise your hand for those people who used CMake. Okay, okay, and then please keep your hands who raised the CPM and fetch content. Okay, so for the rest of the people, how do you manage your dependencies? On repo, one of the answers.
Yeah, not from Git. There's a instance environment.
Okay, via custom shell script or something like that.
Make file.
Just for the microphone, the answer was
Well, make
download
files
from
and
Git
app.
by.
Git use.
Sorry, what was that online? Could you please repeat
They
what
used
you said
make
online?
files and apt. Installation of libraries using apt and normal make files.
So system package manager then.
Yes.
Okay.
Yeah, that's the same for me. System package manager, and the README says the child apt blah before
Yeah,
installing.
Yeah. Some version,
Yes.
whatever is there.
I don't know. I think it were just Java bindings, and it was not very critical
Yeah,
version. But
doesn't change much.
I think you can specify the version in apt.
Yes. Sorry, just to repeat, the answer was system package manager basically. And you said? Sorry.
GitHub modules.
GitHub modules. Okay, so we have a lot of different ways to manage dependencies. And maybe that's the reason why you're here. Even. Okay. Okay, we can skip. Skip to the next slide. Can we skip it now? Hello? Okay. All right, so I made a very small survey here of approaches, and I judged them very subjectively, or very subjectively, against reproducibility properties and against good developer experience properties. Now, before we do this, let's say what I mean by that when I say reproducibility properties. So basically what I want is I want to identify those inputs and I want to build my thing with those inputs, or I want to identify at least not only inputs, right, but also versions of those inputs that were used. And as I said, I wouldn't want that to take 2 months to do it. And that's probably the hard part. Making the machine work like constantly, or running the pipelines in a way that just accumulates the correct metadata, so to speak, so that you have something to come back to later. And by good dev experience, I mean whatever I said probably before. It's just what I do, and perhaps you have the exact same situation. When you want to do active development, you don't care, just use latest version of some dependency, it's probably fine. You just trying to work on your custom feature for your concrete project. You don't care about those dependencies. And you want minimal amount of configuration to set up. And you do not want to like switch GitHub modules or do some kind of merges that require human attention in a way that that's the most classic problem for me personally, or the main pain point is that when you have some kind of dependency chain A, B, and C, where A requires B to build and B requires C to build, and you want to do changes that are simultaneously done into C and into B and maybe into A. So you do changes to C and you need to adjust your code in B and you need to maybe adjust your code in A. Sometimes that happens. And that creates a blocking, basically a bottleneck, because you first need to merge C. Then with GitHub modules, what do? You have to bump B somehow, the merge request in B. Then you need to merge that. Then you need to bump some modules again in A. So it's quite unpleasant to do. It's a lot of things that seem that are automatable, so to speak. And I think I can spend my time better than just sitting and bumping some modules. Yeah, and as I said, zero cognitive overhead, or nothing is zero overhead, but at least let's try to believe that it may be so. And for our small team, again, lowest amount of maintenance, nothing. If something is way too complex, of course we can design some kind of machinery that is like extremely robust, extremely reliable, but we need like 5 people to maintain it, for example. No, that's not gonna work. It has to be, maybe in some cases, it is worth the developer's time to do something, because otherwise the machinery would be too complex. So when you try to come up with something like that, always base your decision on what your team will be capable of. Do not think of it in a way that, okay, I will invent this kind of stuff, and because we now need to maintain this, my manager will hire a DevOps guy. No, I don't think so. You will be maintaining it. So anyways, just these few things, okay? There are many more approaches to managing dependencies, but these are the ones that I considered myself, because other approaches I have directly skipped. For example, using System Package Manager, yeah, that works if you use some kind of Dockerized setup. If you don't, then it's a free-for-all deathmatch, basically. It works on my machine, but it does not work on Click's machine. So with Git submodules, yeah, reproducibility is by design great. Yeah, just works. Good dev experience, not really, as I said. When you have multiple chains, or at least one chain of dependencies, and you need to do multiple changes into the chain, yeah, it is unpleasant, is it? Or do you have some kind of machinery or automation to bump these kind of submodules?
It's usually the manuals.
Manual. So you need to basically, hey, Alex, please merge my merge request, and I will bump the submodule. Yeah.
I remember working with some modules in the past, and from my recollection, you were able to actually update all the components right there in your checkout and push them independently to each their own level. You could build them
So
on the spot, right? So you didn't need to do the push-pull thing, right? You could update both of them in the same place.
But would that work if you have separate Git repos and you have? How would that work though?
But
sure.
Each submodule you add it in the submodule, and
Right.
you can push it to the repo from which the submodule is coming from.
Okay. Yeah. Okay. So the comment from the audience is that you can, when you add submodule locally, you can push changes into the submodule.
Yeah.
Okay, and that would right. That would.
So you have the complete checkout with some models.
Yeah.
Your, let's say, main object repo, whatever you have there, and you can just edit code in each of them right there, and push each of them separately to their own repos.
Okay.
I mean,
you can basically.
I don't really remember. You would have to update your submodule configuration later, but you were able to basically work on the whole thing right there locally on your machine, build the whole thing.
So you could basically fix other people's merge requests by pushing to their branches with your current version of.
So I'm talking just about a work on a single change set by one developer.
Yeah.
Right.
But what if you have a replace strategy merge, and a new commit is created on the main branch, on the target branch? So we don't know beforehand the commit hash. So it's.
So you are talking about the next step when you actually want to merge all the different changes in different pull requests. No, okay, that's a separate step.
Yeah.
Right.
So yeah, I'm talking about this kind of like bottleneck where you have to synchronize them. And
Okay.
you basically cannot omit this step,
Yeah.
but you can maybe automate this step.
Right. Okay.
Yeah.
So that part was actually Conan, and in fact, the Git submodules were just introduced later on top of a project that was already managed by Conan, just so that you could have one version of the whole thing on your dev machine and work on it locally, right? So that was
Yeah.
okay. Yeah. So I was looking on it from a different perspective.
Yeah.
But Conan was the thing for
So
managing the dependency, then later for bumping versions and all that.
So basically also a dual managed setup with submodules and Conan. Yeah. Sorry. The comment from the audience was that initially the project had Conan package management in it, and submodules were added also later. So yeah, okay. Yeah, okay. There is a way. Okay, maybe not the X mark, but okay, possible with further work. Fair enough. Same for fetch content. Okay, that's a good thing. If you need something, if you need to hack something quickly, something to hack up something quickly together, yeah, it's a good thing. Especially the fact that it runs in as a CMake configure step. But it doesn't provide out-of-the-box experience that is really usable in these kind of situations which are more complex or need some kind of automation. For CPM, the reproducibility possible if you lock your dependencies to commit hash. But also, of course, you have to remember that CPM is only a CMake package manager. It does not do any other dependencies. So if your whole ecosystem of dependencies is CMake buildable, and they have CMake build systems, okay, that's that one. I guess you're lucky, but or if not lucky, that is your deliberate decision to only use dependencies that have CMake build systems in them. But that might not be always the case. For us, for my team, it is the case, fortunately. So it's a good solution. And in terms of developer experience, it is quite good. I think it does what it should. It's just a thin wrapper around fetch content and has local cache and a few bells and whistles on top of that, on top of fetch content, which are all useful for me. So for me, CPM is very good if you have only CMake dependencies. And of course, Conan. Now, maybe somebody would ask why no VC package. The answer is very short. I don't know anything about VC package, and I didn't know anything about Conan either. But when I was considering which kind of package manager for C++ ecosystem should I use, I thought that using a product of a big corporation is not a very good idea if you want to go for longevity, because realistically they have the resources to kill any kind of project anytime. And
they vibe code.
do they?
Oh, they're like famous for using so much AI that everything's falling apart. So
Yeah, but I mean, but Microsoft team does not vibe code.
I think this was a CEO push that basically caused
Okay.
the disaster everywhere.
Okay, the comment was that VC package should not be used because Microsoft people are white coding. But anyways, I don't know. Just I remember Diego quizzes for meeting CPP. I mean, Conan all the way. The easy solution. So anyways, regarding reproducibility, great support because it is an actual package manager, unlike any of the rest of those items. it tries to do package managery things at least, and maybe even does them well. I'm not that well familiar with Conan. I'm still learning it on the fly, so to speak. Regarding good developer experience, well, one thing I didn't like too much is that, which was addressed in Conan 2, is that you have to run Conan install separately, which is a little bit of a hurdle, especially when you have a user, developer, who is already struggling with CMake, who is already overloaded by presets or concept of presets, and you just like tell them, okay, here is a bunch of presets, just open your IDE of choice and just select this kind of preset, and it should just work out of the box. It should at least build or something, do something useful, okay, without you having to edit 500 files beforehand.
Okay, why not just have presets as a part of clone package? It's like a basic thing.
Maybe. A comment from the audience was, why not have CMake presets as part of Conan package or packaged as Conan package?
Not just CMake, Conan presets. Configuration.
You mean Conan provider?
Conan, sorry, I kind of lost the terminology, but it was like.
You mean the CMake module that allows?
I mean, just the YAML that gives you like what you need for everything. Well, my use case was that we had everything in Conan and Artifactory. There were like blobs of binary stuff there, and we kind of needed like actual reproducibility, which meant that we had everything in Conan and Artifactory, including the toolchain. So it was like compiler was there, C library, everything else was there. And it had to work like actually reproducibly. So we had like patches just so that compiler didn't inject stupid timestamps and the Shahidi sets to like actually match. So it was like actual reproducibility.
Comment from the audience was that one way to achieve reproducibility with Conan is to create Conan package with your toolchains and everything, all input into your build, and just treat it as a normal Conan package. So just distribute it via Artifactory.
Well, there are like build packages, and there are like the stuff that you actually link and ship with your binaries. If you have like the producer model, I'm not sure if we are talking like the consumer model of Conan or producer or combination of both.
Not sure. You tell me.
Well, if you read the documentation, and I remember correctly, I'm kind of out of the loop for a while. There is like several use cases, and like basic use case is just the consumer model. You do Conan install, it kind of gets you the stuff into the root folder, and it's kind of ready to be packaged. But if you also want like to be producer, create your own library or something like on push into master, like CI machine creates like takes the version of like major, minor, and then the build version is gonna be whatever the build number is.
So in our case, both. In our case, both. You want to both require some dependencies, and you both provide yourself into or upload yourself into Artifactory or build yourself. But we'll get to that. That's for internal dependencies. Yeah, that's one of the approaches to make it all work. So, sure.
We're saying that there is a problem with the extra Conan install step, and there exists CMake Conan, which is which makes it a bit easier to run Conan install from the CMake. But in my experience, it has its own problems, and depending on the environments, it might be easier to just publish to the repo a PowerShell script or Python script that creates the environment. But,
Yeah. So the comment from the audience was that there exists a CMake list file that is injected during the first project call in CMake. It's called Conan Provider, and we will use that actually later because for exactly that reason that it runs Conan stuff during CMake configuration step, which allows you to simply do just that, to simply select your CMake preset. And by the way, I noticed, I don't know about other IDEs, but for example, in CLion, if you select a CMake preset, you cannot even edit there. You cannot even edit anything in there. So you can only enable it. And if you want to do anything besides that, you're basically on your own. Sounds a bit strange to me, but maybe that had its own justification. I would expect to be able to enable preset and on top of that, make some of my custom changes. For example, I want to change just one cache variable. Just enable me to do this. I don't want to generate 1,000 user presets for that. But that's an IDE usability issue. So from command line, there is no issue. You just write CMake, for example, -- workflow and the name of the workflow preset, and then -d whatever. It works. You can override cache variables like that from command line. Can it work? For some reason, my arrows do not work properly after some time. Anyhow, basically, I've already covered some of that information about CPM, but specifically what I wanted to highlight is its usability for day-to-day development. So some of you who have developed projects, I don't know, like 10 years ago, maybe 5, 10 years ago, perhaps faced the same issue of dependency management. And back then, the idea was to create some kind of super project that only has CMake code in it. And it uses external add calls, which build your dependencies and your project and everything as a build step. So as a build target. So in that super project, your configure step runs, your generation step runs, and then during the build phase, it builds the rest. That was how external project add worked. Until some Australian guy, I don't remember his name, but the author of CMake book added fetch content in like CMake 3.15 maybe, which enabled people to build their dependencies at CMake configure step of your own project, which to me is a big improvement because you know directly if your project, you don't care about those dependencies. You just want to make them buildable and you don't want to build them at your build step of the build step of your project. You want to build your only your targets there. So that's a big improvement. And CPM is an improvement on top of fetch content, basically. For those who are unaware, CPM is basically CMake package manager. You can find it on GitHub. If you just write CMake package manager, CPM, you will find it on GitHub. With some additional functionality against fetch content. So it has a very useful feature, source overrides, which means that imagine that you have project XXX and it has 5 internal dependencies, 5 libraries, and you just clone them near your project XXX, and you just specify -d name of that dependency underscore source, or CPM name of the dependency underscore source equals path to that dependency on the disk. And when you do any kind of changes to your dependency on the disk and you have dirty Git work there, basically, you can build with that state instantaneously. So you don't need to do anything. You don't need to do any more configuration. You just override that path to that dependency. Meanwhile, your CMake project still refers to that dependency as it was referring by CMake, by, for example, CPM add package, for example. It also has local caching, which is also very useful because build systems like Make or Ninja are not really, how do I put it? Are not that good of a build systems, which means that you may end up in a state where after some iterative builds and changes, it may result in incorrect builds because it will pick up old dependencies that should not be there and will link against them, for example. And neither Make nor Ninja do not solve this issue. And CMake, of course, doesn't do that too because it's just a meta build system. It's just a build system generator. It's not a build system itself. Or maybe in some form it is because it supports like execution via script mode. But still, the point is that, okay, what I was going for is that because of this behavior of generally available build systems such as Make or Ninja, you have to frequently remove the build directory to be sure that your build is actually, the result of your build is actually what you want to get, or you want to make sure that your project builds cleanly. That's an issue which is, I don't know, like 30 years old, 50 years old, I don't know. Anyways. Local cache allows you to configure your project very quickly because once you remove the build directory, that means that by default, CPM will use underscore deps, like dependencies, directory created in your build folder. So that means that whenever you rm minus rf your build folder, it means you have deleted all your downloaded and built dependencies, which may take a while to rebuild. So CPM has local caching override for that. And it allows you to run the configure step much quickly. It also supports some kind of log files, which are basically just CMake calls. I will show that later. But there is an abstraction. You can think of it as a log file. And it is also very useful, and we will use that later. And as I said, again, it is CMake only and it is source only. On the other hand, maybe that's a good thing because you don't then have to manage any kind of binary compatibility like Conan does. You don't need to specify your toolchain, which has your specific like compiler, major version, standard library, additionally, if it's Leap C++ or Leap C++, etc. You don't have to think about it because basically you just build everything from source. Yeah, and also with Ccache, again, if you just configure Ccache globally on your PC, I just did it for any project on my PC, and it significantly improves the build times again because you sometimes just have to remove that pesky build folder. Okay. Now, maybe a short information about Conan now. As was mentioned by the audience, it is possible to run Conan as in terms of a CMake configure step. And I don't know, that's how I would use it. And probably it if it didn't allow that, I probably would not use Conan, would not have used Conan because I'm just too used for this kind of workflow. And yeah, for external dependencies, it's just great, but sometimes you also need to manage internal dependencies, and that's where it begins, basically. Also, again, since Conan is trying to be like a proper package manager, it allows things like CV lookups, it allows licensing audits, it allows creating SBOM, which again these days is very important because of regulatory pressure. And yeah, regarding Conan provider, sorry, you need at least CMake 3.24 to be able to use this CMake project top level includes variable, which is a list of file paths that are injected at the first call of project function. So the very first project declaration of the topmost list file is when via this variable, any CMake file can be injected. So that's how you can do code injection now in CMake. Quite useful. We will for another thing also, not only for Con provider. Yeah. So for us, I consider that CPM plus Conan is just or might just work if we try to think of something of some kind of additional logic around that. And the reason why I wanted to at least somehow use Conan, I would have used CPM because it's pretty much enough for my needs, except for example, versioning and again, SBOM and things like that. So I wanted to use a proper package manager, but I did not want to give up the developer agility. And by that, I mean things like overriding local stuff and not being, for the developer, not having to work with a local cache to export some dependencies, some Conan dependencies into local cache and things like that. Or just even knowing that they need or want that, or just having to learn a new thing. Why? You can just achieve things with, if you can just achieve things with CPM by adding one line with a source override. So our actual solution is based on that. And the CPM part is, I treat it as developer oriented, and the Conan part, I treat that as oriented towards production builds, DevOps kind of tasks, for regulatory tasks, for some kind of official auditing and things like that. Yeah, and again with CPM you can do reproducible builds, as I later found out, by just, for example, using multiple log files. And that is where I will next continue. Basically, the approach is that we always use Conan to manage external dependencies, because that is even much simpler than using CPM for that. Because when you use CPM for that, you have to know the CMake options, and you have to, for example, disable tests, disable, I don't know, profiling, whatever. Conan does that for you by default most of the times based on what the recipe authors wrote there. And usually they do something insane and disable things that are not needed. And also, but then again, with some dependencies, I found that the Conan recipes were not as flexible as I would have wanted. So again, maybe if you need more flexibility and you are willing to configure your dependency via CMake variables as you need it, then maybe CPM for that concrete dependency is a better approach. But again, for external dependencies, it just doesn't really matter. You can use anything for them because you don't edit them, so they don't change often, and that is that. And for internal dependencies, there are two ways how we can do it. You can manage it by CPM or you can manage it by Conan. And you just have a CMake variable to switch that. That is done by creating two log files for CPM and two log files for Conan. We'll get to that. These log files have CMake targets. So, for example, for Conan itself supports log file generation. When you call Conan create log or something like that, you can wrap that in a CMake script. So CMake dash big P and the name of the script, which does not require you to write any kind of configure step or build step. It's just treat it as a bash script basically, but written in CMake. If you didn't know about about CMake script mode, so in a CMake script mode, there is or we wrote a way to just call this Conan create log with correct tool chains and things like that, and it is also customizable by some further CMake variables to meet our needs. And eventually, you can have automatically generated log files for both Conan and CPM. And CPM itself has log file target, which simply dumps a list of your dependencies with a call to CMake declare package. Oh, sorry, CPM declare package into some file that you specify. So usually for CPM, it's easier to edit this by hand because usually you face the CPM log files much more often as a developer on your local setup. And yeah, and basically the main idea is that Conan is the official way via CI, or the CI uses it. And yeah, the developers can get enough with CPA. Now, as I mentioned, two log files, package log and package log floating. Basically, the one with the fixated or fixed up versions of those dependencies, and the one with floating reps. So, for example, your master branch or your feature / whatever branch. And additionally, in your CMake logic, there is a variable like project CPM floating that should decide whether to use the fixed up version of the log file or the floating reps version of the log file. And the version that uses floating reps, be careful with that because you also need to set a few fetch content variables so that you disable the disablement of the full download or whatever it's called. The point is that fetch content has some optimization by default in a way that it does not refetch things for you when you reconfigure your project. So if you want to use floating refs and you've pushed something somewhere and you actually want your project to fetch those changes always actually fetch everything, then you need to disable those few fetch content variables or set them to off. I don't remember exactly, but I think something fully disconnected and update disconnected or something like that. Regarding CPM, if you have used CPM before, then the README of CPM usually tells you to use CPM add package or CPM find package. But if you use that, it means that you basically declare and populate your dependency at the call time of CPM add package, which is not always desirable. Because then you would not be able to use log files, for example, where you just declare your dependencies and then based on your internal CMake logic, you call CPM get package, which may or may not happen even. For example, it may not happen because I have some other CMake variables that tell me I don't want to use ETL, for example. And you can think of declare and get pair of functions for CPM as a declaration and instantiation. During get, you just instantiate or populate your dependency, which may or may not happen. And for some reason, CPM does not document. I think it does not document the declare package function. You just have to look at the source code. So I don't know. It documents that it supports this kind of log files, but it doesn't show you that well, in my experience, how to actually use them. So yeah, this is the pair of functions that you need. And from the Conan side, there are two logs, as I said, also, but of a different kind. The normal Conan log, the generic name for the Conan log, which Conan generates by default. And we decided that it would contain external dependencies only. And do not look at this Python requires. It's an internal dependency, but mostly this is to showcase that here's just a list of some requirements as opposed to this list of requirements, where you can see that this is based on some conan.internal.log, and it lists some internal dependency here, which depends on ETL, so ETL is also listed now. So yeah, it is what you would expect from a log file, just full graph of dependencies. And this would include the internal ones and any of their recursive dependencies, basically, or transitive, dependencies.
Where you have two CMake there.
Sorry?
The build requires, you have two lines for CMake.
Build requires. That's because I think some of those dependencies above want a specific version of CMake. So yeah. Okay. Yeah, I think I should spend a few minutes on explaining what you see actually with this Conan log file. So Conan has a few kinds of dependencies, as far as I understood. There are build dependencies, which are not needed at the point where you build your application, but they are needed to build one of these dependencies. I don't know which one, because that's flattened, basically, Conan file. And this will not be needed later, the build requires. The requires are needed to be installed, need to be built and installed, and then basically what happens is that when you call find package in your CMake list file, Conan interjects the find package call and replaces it with their own logic, which provides the correct paths to these dependencies. And regarding Python requires, this is a way that I found out how I can add some Python logic to Conan files because, as was mentioned in the audience, there are apparently two ways to do things with Conan, via consumption and via production, or both. I think for consumption, it's enough to have Conan file.txt, where you only specify whatever dependencies you want to download, build, install, and to be found in your project's build. But with production, not only that, but also how to configure, build, install your internal dependency, basically, or yourself when you build the project. And for that, you need the Python version of the Conan file. You can use either Conan file.txt or Conan file.py, and .py version is a normal Python script where you import Conan library, Conan Python library, and pretty much you can do anything with that, whatever you would want to do with Python. And Python requires is exactly for that. So Conan helpers is basically a Conan package that contains contains a Conan file which exports some Python functions. And I can then import these Python functions in my project that uses this log file, for example, and I can call them normally. So that is how I can share some subroutines, useful subroutines that I call, for example, in every project x66, y, and so on. And in my concrete case, I use that for versioning. So I have a subroutine that calculates the proper version according to some logic. And it lives in those Conan helpers. And with config requires, I have no idea what that is. Does anybody know? Okay. So anyways, config requires maybe next time. Okay. Back to dependency management, specifically internal dependency management. As I said, you can choose whether to use Conan or CPM, and it is as simple as just an if, where you either call find package. As I said, Conan will interject your find package call, or let's say, let me specify. If you use Conan provider, which is a CMake module, as I mentioned earlier, which allows you to skip the Conan install command before you do your CMake configure command. It runs Conan specific stuff in terms of CMake configuration, or at the same time. It will interject find package. I am not sure if that is the way it works when you Conan install or not, but for Conan provider case specifically, in CMake, I think 3.24 or 25, there is a new way to call CMake language to register some kind of hook, and that is how you can inject your specific code to do something else. So, for example, perhaps some of you may remember that there is an old CMake hack where you can put an underscore in front of the function, and you can write your own function with underscore and the same name, and that is the function that will be called. And I think it even works in a way that if you put, for example, two underscores in front of that, it will override the one which has one underscore in front of it, something like that. So you can even do these kind of things with that. But of course, it's a hack, and it's not recommended. And I think CMake developers tried to address this concrete need via allowing registering these kind of code injections into the CMake language. You may look at Conan provider on GitHub at the exact call that I'm talking about, which does this overriding of find package call. And yeah, you can use that for your own logic somehow. And as I mentioned, you will either call just find package or you call the CPM specific instruction. Not too complicated. Now, here we approach the territory which is still a work in progress. And maybe this part of the talk is more discussionary in terms of that I don't have a working solution or a definitive answer, let's say. I don't have a definitive answer to certain topics. So for example, okay, we solved this dependency management issue for project XXX. What about other projects that also are fundamentally complex, and I also want them to behave similarly and to use the same kind of machinery? The one of the answers now that I know is that you can basically create a common package out of that and package it like that. It did not occur to me that that's a way, but maybe that's because I haven't spent too much time fiddling with Conan yet. Another approach would be to, again, apply the similar logic that you use CPM in the first place or Conan. It is that you want to download the precise dependency. And here is a classic chicken and egg problem where you don't have CPM yet and you want to download something that would contain CPM in itself or a common provider, but you don't have that yet. And also there is further issue that you can only inject things into the top level project include once.
It's like if this CMake script that kind of goes to GitHub, downloads Conan for you, sets it up, and then you can continue. So you basically don't need to do anything like that.
Yeah.
You need to run like a CMake configure that will actually download Conan for you. And
not necessary. You can even write a CMake script mode.
Yeah.
CMake script.
You could do it yourself,
Yeah.
but yeah.
Yeah. What you mean is basically file download, if I understand correctly. Yeah, so the comment from the audience is we can easily solve this issue by, for example, writing a CMake script that calls file download subcommand that just downloads whatever version of CPM and common provider list files that I need. Yes and no, because firstly, I would want something external to manage what versions of CPM and common provider list files I want to get. Because I want to configure it once at a certain place, and that would apply for project XXX, Y, and so on, for the whole family of projects. I don't want to come back to each project and edit it separately, because it's just like kind of duplication, and also it also in some way promotes separation from like other projects. So imagine that you have a project leader for project XXX and project leader for project Y. The one in project XXX does his job diligently and bumps these dependencies from time to time, but the one in Y doesn't do this. And now the projects have diverged and potentially may face issues because they also use some common logic behind that. For example, as I mentioned, the log file generation CMake code. So there is some kind of additional CMake code. And that is the second reason why that is not too viable, because besides those open source dependencies, you need your own dependencies from your private GitLab, for example. And for that, you would need some kind of GitLab token or something like that. And it gets a bit more complicated because what you want is just again get everything as one piece basically, or your CPM content provider, additional logic around CPM or some kind of shims, etc. But that's the point. Instead of writing a shim for each single project, just somehow get them into the project. And one way that occurred to me that can work and does work actually with the dev container is by having a separate repository that has the dev container config JSON. Let me introduce dev container for those who have not heard of it. This is again another Microsoft idea of having a basically Docker file that basically has a way to be launched. So basically some kind of Docker Compose style of using a Docker file, but it creates for you this nice abstraction that you can do the alternative of exec-it into the container, but in terms of VS Code, so as a GUI. So you can basically attach to that container, and dev container is nice sugar around it. Maybe it's not even needed, but I haven't tried it before, so I decided to try it out anyways. And this kind of works. If you have a separate Git repo, which has checked in versions of, again, CPM, content provider, some source, CMake code, those content helpers that I mentioned before. So right now I decided to do it a bit differently. Instead of having those Python scripts in a separate content package, I just do a single repo with the dev container config. And then you have one single variable, for example, CMake helpers root or this repo root, which you pass. Here it's called CMH, like CMake helpers, but maybe it's not the best name for it no anymore because it has dev container config in it. So it's just basically like a development setup for any kind of project x86 like project. I think it makes sense because again, that is yet another layer of simplification for the final user, for the developer. All they need is just launch this dev container and attach to it in their IDE if it supports that. As far as I'm aware, VS Code supports it, CLine supports that. Qt Creator, I don't know. I don't use Qt Creator, but my colleagues use Qt Creator, so we will see if it supports that. If they complain, then probably not. And yes, also dev container supports Docker Compose files, which is great because you can basically infinitely override them. You can have main Docker Compose file, you can have project-specific override, and you can have local override that is not that is git ignored, for example. So yeah, that is one way to address that. And again, as I was running out of time, going here by the metro, here are some other topics that I just dumped into the slides, which are somewhat relevant. Again, as I mentioned, for us, we use commercial Qt extensively, and that means that every developer has to specify the path to their own Qt installation. Well, of course, you could enforce a standard installation, maybe, but that would require agreement between people, and that is too hard. So the simpler solution is to inject your path into CMake prefix path that points to the something GCC 64/lib/CMake, and that's the root for CMake config files in Qt. And that would require you to edit some, for example, some base template, base preset, so that it propagates through all those presets. But by editing that preset, you need to derive your own presets out of that, as I mentioned earlier, and that is quite inconvenient because that results in a lot of boilerplate that is untracked. And also, if you change the main preset in some kind of backward incompatible way, the user will have to change their user preset, and that is very, very unfortunate because you cannot realistically expect users to keep up with these kind of breaking changes. And these breaking changes may come because, for example, you want to add static analysis and it turns out you derive from some kind of GCC preset, and now you need to separate it into a different compiler, and it's that basically. So some kind of like, again, trick, or as I mentioned, exploration maybe of this variable that common provider uses. As I mentioned, that you can use it for your benefit as well. In my case, I figured out that you can create some kind of user config.cmake where you write cmake syntax. So you use set cache, but also you force this parameter, which means that it force overrides whatever is set in the cache. And I haven't yet tried that, but that should work because you would end up with, or if it works in a if in a positive outcome, then you will end up with just one line of, not one line, but user edited one line of set command that just sets your CMake prefix path or any other variables that you need to set, and you don't need to derive from a million presets in your user presets. But in general, the preset combinatorial explosion is a known problem. There is a GitLab issue on CMake GitLab about that from 2021, I think, and it is still open. And there are some various ideas how to address this, but I don't think that it has been ultimately addressed or that there is some kind of way forward currently. So unfortunately, for huge projects, I mean, for example, like 30 CMake cache variables that do something useful. Because of that, it sometimes doesn't even make sense to use CMake presets, unfortunately. And it's easier to write the exact -d like things out. So yeah, your mileage may vary. Our project is small still, so presets is a justifiable solution. But even with that, and even with one compiler toolchain, we already have like more than 1,000 lines of default CMake presets. And you would have to have like 500 lines of user presets on top of that. So that's a neat trick that I think that may work. And in terms of combining this with common provider, you just call include, like include with parentheses, and you include your common provider in site user config.cmake, and it should work, I think. Okay, and this slide is probably my question to you, or especially to people who use Conan, what you would advise in a situation where, again, currently I have one single big Conan file that is for the whole project x86, which defines different, basically independent sub-targets, or let's say it has subfolders, which do their own thing and potentially may have their own dependencies, and they do, both external and internal. But in terms of internal dependencies, I'm able to manage that more easily, of course, than the external ones. And currently it just lists all other internal dependencies from other Git repos and all external dependencies for core, GUI, some library x86, whatever. Whatever they need, the whole package it lists in one Conan file. The main problem here is that for some reason, I have a feeling that if you use Conan provider, then you can only use it with one Conan file, .py. Does anybody know if that is true or not?
Why would you need two Conan files? You're developing one project.
Why do I need
Just
two Conan
projects.
files? Because I would like to package my core x86, I would like to package my GUI x86, and so on.
So if there are separate projects, you build them separately, package them separately, then they are separate. But if there are two libraries in one project, you package them at the same time, you version them at the same time, then it should probably
There
be
are
one
two
project.
libraries, either it should be one library or you should have two packages for two separate libraries. Like there is no point.
Yeah, then there is things like Boost, which have like components and many libraries.
Yeah, but you have a Conan file, it's extremely complex Conan file for that.
Yes.
But you can specify I want these components and then just say file package, boost components, whatever, and it's gonna pick it up. Like there is no issue there.
Yes.
You can define it in Conan file like there is a dependency thingy, and you can specify that you want these things, and it will pull it down and get it for you or build it if needed.
Yes. So I think it really depends on your business.
Okay, you wanted to say something?
Well, just ask, I would like to ask about options, like if you want to.
Yes, yeah, I have probably skipped that because I was in a hurry. But yes, I also, regarding Conan options, I added,
For this specific case, like you
yeah,
want
for this
to
specific case.
package lib or executable, you can switch the option.
Switch the option of what I want to currently build. Aha, so you would suggest to rerun.
You default pattern for if you want to build a shared library or a static library, for example, you
Yeah.
can just switch this with an option. So
Okay, so you would suggest here rerunning the CMake configure step and then building one single target here. And then in CMake configure step, you would specify a Conan option that only enable, for example, core x86. Is that what you would suggest? Did I understand you correctly?
what do you mean by enable that? You just package the one thing that you want.
Yeah, but you do that via like Conan option. You need to pass Conan install args to it. Yeah, okay. Okay, so that is maybe possible.
If you have like a Conan file, you just specify you want shared or not shared, and it will do the right thing. It will fill out the CMake parameters where needed, dependencies if they need to be built, or they will be pulled from the Artifactory, just the right thing. So you don't have to care or even know where your stuff is, because basically the idea behind the Conan and especially Artifactory is not just that you have local cache, but you don't even need to know where your build is, because it's gonna be somewhere in your home folder if you are on Linux, and it's gonna be behind some hash, and it's gonna be completely separate from your source code. So if you do it like provider slash consumer concept and build it in one step, like in one build command, then basically it generates the new thing in your home folder. It's gonna run for your project. If you have some unit tests, it's gonna run it there against the clean build that you just created. And then it will say, okay, this is my package. you can do the version hack. You can say build for your local branches is 10,000 or the 100,000 version. So it will always use that one, and you have like a local thing for you. But when you want to like log against a specific version from your CI, you just modify the Conan file like dependencies version, and you say, okay, I want this dependency to be logged in this, but the semantic version higher than this for everything else, and it will just do the right thing. Like you don't have to care or know because like Conan does it for you. And it generates like the solution file in Visual Studio, Xcode file, or Ninja, whatever. It just works. Like if you like never want to do like if branching or like CPM stuff because you can do like on the lower levels than you, but as long you have your package, it shouldn't propagate upwards because you don't want to inject shit from your lower packages to the upper packages because that creates like a stupid dependency that you don't have to have.
Regarding this kind of injection of dependencies upwards,
Okay.
one idea that I had for the CI approach, which I do not cover by these slides, it's completely at the end somewhere. Basically, that was showcasing that it uses one concrete Conan file.
Yeah.
And this is the example or the exact call that I was mentioning that overrides find package. And I wanted to ask about or discuss maybe some kind of package promotion mechanism where again you have A, B, C kind of dependencies, and then you do changes to C, and you want to take B and also test that with that C, it also builds that merge request. So you have like 3 merge requests, which are dependent on each own. So B needs to check out the merge request version of C. A needs to check out the merge request version of B, which check out the merge request version of C or something like that. And what you want is to probably have some kind of different channels, maybe, where you push, where you have one Conan channel where you push the version of the built Conan package of that merge request, and then you have it linger there, and then you take project B and do the same, and also in project B you take that staging version of C that was pushed and built by Conan, and so on. And when you know that all of them built successfully and some kind of automation merges all the merge requests in a chain, for example, some kind of merge bot, then it promotes those packages from like lingering or unstable state into like normal default packages that would propagate into log files eventually of these packages. Would that kind of system
recommends using different Conan
Sorry?
repository for that? The Conan project, the guys running the Conan product, they recommend using different Conan repository for that. So you have your
there is
stable
still
repo.
it's called the release channel, I think.
Uh-huh.
I think the channel is a different thing. So it's part of the reference. The channel.
From the audience was that the developers of Conan recommend using different Conan repositories, you said?
Yes.
Where you push your packages.
Yeah.
And then you can promote when you promote the package, you move it from one repo to another. And if you use the Artifactory, the paid for Artifactory, there is some nice thing to do this, but you can do it with the free one.
Okay.
They have some talks about this online.
Okay, great. Can you are you on Discord? of C++ Meetup?
Yeah.
Can you send those talks to Discord?
I can do
Okay. Yeah, so the comment from the audience was that Conan developers have talks on how to do the package promotion or how to implement that with the help of Artifactory. So yeah, I'm interested to see that. Yeah, some of the things discussed here were already covered. Basically, I see that all of them were covered, and that is pretty much the end. Maybe a few words about me. I work at BTL, we do medical devices. If you want, write me a message or something. And that's all. Thanks. Maybe any further questions, notes, comments? Yeah.
I have a question about the CPM. I'm not so much familiar with it, but with Conan, there is the advantage that if you develop, for example, images, you can switch from them to editable mode, and you can
Yes.
use both from your file system. So is there something equivalent for CPM? You use it for internal projects?
Yeah. The question was, Conan has a possibility or a functionality to switch package in the so-called editable mode. Is there an alternative in CPM? And if I understand correctly, what the editable mode does is that you can use the local basically override of that package. Is that correct?
It basically points, for example, to a different folder on
To a different folder on disk, basically. Yeah, that is exactly what I mentioned about CPM a few times, where you have the CMake variable CPM underscore name of your dependency, which was declared, underscore source, all caps, source, and CPM also all caps, equals some folder on your drive. So that is, I would say, the exact alternative that allows you to locally override things for quick building. So yeah, basically, maybe that is the actual functionality that would cover the advantage of CPM in this case. I think I read about editable mode, but I completely forgot about it until you said it.
If you gave up basically by creating some Docker container, when like you try to do the reproducibility thing with CPM or Conan, but then you slap a Docker container with fixed dependencies there. Why would you not put everything in the Docker container?
The question from the audience is, since we are already trying to use Docker containers and dev containers in that manner, why wouldn't we basically version everything inside or in terms of that container and basically make it the source of truth, if I understand correctly? Okay, so there are maybe multiple reasons for that. One reason is that in the future, it is possible that this project will be extended to be buildable by Yocto project, which is another kind of software build system. And it is, well, in my opinion, like the best software build system ever, or the best one I worked with. Extremely customizable and most often only one way to do things, but
I have
not
very bad
everywhere.
memories for Yocto.
Yeah, it has its learning curve. Yes, I agree. It's rather steep, but I think especially with Yocto 3.0 and up, it is brilliant. Especially if you work in embedded and you need some customized Linux, and it's exceptional. I wish a lot of projects or a lot of package managers were inspired by Yocto project in terms of how it systematically solves the issues. But regardless, Yes, so one reason is that I would like to make project x86 itself the source of truth and not the generic dev container that would have a developer setup, basically, a generic developer setup, which would be able to compile project x86, project epsilon, and so on, and their dependencies if you want to work on them individually, which would also be the case quite often. So yeah, that is, I guess, the primary reason for that. Basically, I would like my project x86 to be the source of truth, ideally.
That makes sense. At work, we have some similar concerns where we need to be able to easily reproduce the build environment for the devs. But we use Conan for the dependency management, and we use Conan to also ship all the dev tools. So we don't require CMake, we don't require, we require MSVC, but let's ignore MSVC for a second.
Yeah.
And imagine we build everything with Clang. We do ship Clang also as part of Conan. So basically the developers just have to need to have Python installed on the machine and Git. And then we have a script downloading the right version of Conan and running the Conan install with the right parameters. And then it puts all the different tools needed, all the dependencies, and that's the only thing that we need.
Okay, yeah, maybe
It works across Mac OS, Linux, and Windows. Which is pain, but that's an alternative.
All software engineering in Spain.
Yeah, you can try to look into that direction also.
Yeah.
So it also ensures that if I check out old commit from a year ago, I have all the tools, and it pulls down all the tools from the version a year ago. So I don't need to like if you have the dev container, you would need to use the image from.
Okay, but if you have like CMake, you probably also package your code with your CMake packages. So
yes,
so that's the answer.
Well,
you don't need to check out anything because it's already there. It's inside the package.
Yeah, but not for the dependencies, the toolchain, and so on.
Of course, yes. Those are also CRCs. They are separate packages and they have their own source code and separate like build artifacts.
Yeah, but we can do this because we have everything shipped through Conan.
Yeah, that's my point. Like if you use Conan, you can just do it and don't do like that.
Yeah. That's my point.
Yeah, okay.
Yeah, so the comment from the audience was that basically you can scrap all that and just use Conan. You can package your toolchains there. You can package your shared CMake list files there, and you can just call Conan install in a script to bootstrap your build environment, including omitting the necessity to use some kind of Docker file for easy local setup. Find some creative.
Like I can inject like why we did like that in our company where I use it like this. We had a big fuck up security issue when somebody hacked into our code signer, and basically we couldn't trust anything, including the like Git. So we got kind of fucked, and we had to like build into environment from scratch, and basically all releases had to be put on hold because we couldn't trust anything. So we had to like start with the greenfield, but with like many years of share base. The thing that was made developed was like reproducibility, but also it went like from the source code. Everything had to be built from the source code in the new environment, and there was like developers couldn't touch the new environment. So it had to be made in such a way that it would work on the CI machines that we had no access to. So
yeah, that was also my idea behind having Conan only Conan to be used in CI to somehow protect the to omit some kinds of supply chain attacks. But that's interesting.
Nowadays, I think Conan supports this, but also there was like verifiability. So every package was also, we had like an X back then, but every package was like code type, including the source code and the products, and all the chain that had like when you created the final package, like I want to ship this, everything, including the binaries, was in the like manifest, and it was like verifiable, hashable, and had to be pulled. Not, it couldn't be built. It had to be pulled from the Artifactory and then checked. Like every package was checked for hashes, so that it would like be actually
I see.
from the thing, because like we couldn't trust anything. So
I see.
that was our
that's
small project.
Yeah. Interesting that I've never heard about such kind of attack onto the infrastructure that you cannot even trust in like XZ attack, but multiplied across the whole company, basically. In terms of that, that is the reason why I like Kyoto project. Is that because you can build, or it is designed to build anything from the source, and and you can patch things out, or it has great like patching mechanism. Yeah, so that is that, I guess. So yeah, thank you.